Hey everybody! The purpose of this video is to give you an alternate solution to question 2.13.15 in the Collaborative Statistics textbook. This one already has a solution. It's given to you. This is part C, actually. Make sure you know that. It's just part C. This is the part we attack in the variation homework. The reason I'm making the video is because it came up in class. And the question is, given these two data sets, which one has the highest standard deviation or the highest variation? And inevitably, folks said data set B. And I said, hell's yeah. And then a number of students said, why? Why is data set B more variant than data set A? And I think the reason, the intuition clicks perfectly, but maybe making it a little more concrete would be helpful. So here's some stuff we can decide about both of these data sets, and this goes back to measures of center. Both of these data sets essentially have the same average. Now what I've done, the pink numbers on the top are the frequencies. So we've got the data points 1, 2, 3, 4, and 5. In data set 1, there's 1 1, 4 2s, 5 3s, 3 4s, and 2 5s. In data set B, there's 5 1s, 4 2s, 2 3s, 3 4s, and 6 5s. I've put those numbers on, they're relative. I have no idea how many there actually are because the book doesn't tell me, so I've tried to scale them accordingly. If you want to, you can make them all twice as big, but I've tried to keep the relative sizes of the bars essentially the same. And for purposes of argument, that's not going to change the relative nature of the standard deviations or the averages. So anyway, one thing I think we can all decide on and agree on is that the average of both of these data sets, the balance point of both of these data sets, is going to be 3. I don't think that's too hard to believe at all. Not hard to believe at all. The question is, what's their standard deviation? Now, one way to do this would be to simply run L1, L2, 1 var stats, L1, L2, 1 var stats, and calculate a number. But I kind of want to do it a different way. It's going to be a little less rigorous, a little less formulaic, and a little more intuitive, and I think it'll drive the point home pretty nicely. So what we're going to talk about is, what is the standard deviation of any data set? On average, it's how far a data point is from the average. So in order to know the standard deviation of a data set, you have to figure out, on average, what the distances are from center for each data point. So here's what we're going to do. Let's look at data set A first, okay? And let's make a list of all of the distances from average that these data points in data set A occupy. Well, if the average is 3, there is one data point that is 2 units away. So one of the distances we have to average in our standard deviation calculation is 2. There are 4 data points that are each 1 unit away from average. There are 5 that are right at average. There are 3 that are 1 unit away from average. And there are 2 that are 5 units away. And I'm out of space, so I'll put it over here. Ooh, excuse me. There are 2 that are 2 units away from average. So, in order to think about the standard deviation of these data values, we'd have to average those right there. We'll come back to that momentarily. What I want to do is, same exact argument, but down here in data set B. How far are the distances from average in data set B, and how many of them are there? Well, they're the same distances, aren't they? There's data points that are 2 units away, 1 unit away, no units away, 1 unit away, and 2 units away. So let's start with this. There are 5 data points that are 2 units away. 2, 2, 2, 2, 2. There are 4 data points that are 1 unit away. 1, 2, 3, 4. 2 that are no units away. 3 that are 1 unit away. And 6 that are 2 units away. Now, what I want you to do is to focus on the values here versus focusing on the values there. And hopefully you notice something. Hopefully you notice something. There are a number of zeros, ones, and twos in this data set, and there are also a number of zeros, ones, and twos in this data set. I'm going to remove the averages because they're not really necessary anymore. So the question is, which of the two data sets has larger values in it? Well, clearly this one. This one's got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 twos. This one only has 3. This one down here, 1, 2, 3, 4, 5, 6, 7 ones. This one's got 4, 5, it's got 6. No, it's got 7, excuse me, it has 7 ones as well. This one only has 2 zeros though, and this one's got 5 zeros. So in other words, the numbers on average are larger down here than they are up here. I know there's more numbers down here, I do. I understand that there are more numbers, but percentage-wise even, there's a high percent, 1/3 of this data set is 0, right? There's 15 values. If I, 1, 2, 3, 4, 5, 6, 7, yeah, 15. 1/3 of the data set is 0, which means there's no deviation at all. Down here there's 8 times 2 is 16, 19. So roughly 20 data points. I'll call it 19. I'm going to make it 20 if that's okay with you guys. Only 10%, not 1/3, not 1/3, but 1 in 10 are zeros. Conversely, looking up here, 1, 2, 3, 3/15, or 1/5, 20%, only 20% of this data set is quote unquote far away from average. Down here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Half, more than half, if you use 19, I'll use 20 again. Half of the data set is far away from average. So I ask you this question. If so much more of the data set in data set B is further from the center point of data set B, doesn't it necessarily have to have a larger standard deviation? And the answer is, of course it does, because you're averaging larger values. This is where you have to kind of get used to the feeling of what standard deviation is telling you. Standard deviation is an average distance of data points. So if you've got a larger distance percentage-wise of these data points, you necessarily have to have a larger standard deviation as an end result when you average everything. Hopefully that makes sense. It's a little bit seat of the pants, and it's definitely not exact. A, I didn't use the exact average. B, I didn't use the exact standard deviation formula. But whether I used it or not, the idea of variation sinks in. Hope that helped.